We're up to 9-5, hyperbolas. So here we go. Now you've been taught parabolas, which I think are the toughest. Then ellipses, get a little easier. Hyperbolas, I think it gets even a little easier. So with that being said, there's really only two kinds of hyperbolas. Just like there's two kinds of ellipses. Ellipses, they're either long along the x or they're long along the y. You've got two kinds of hyperbolas. These two parabolas facing opposite directions, facing the x direction, that's called a hyperbola. Same thing here, but these are facing opposite directions, going up and down the y-axis. Now, again, if you like the Pac-Man analogy, the Pac-Men are going to be eating the y-axis. You want to think of it that way? And that's why it starts with y squared. In this one, the Pac-Men are eating the x-axis, and the dots on the y-axis, or excuse me, the x-axis, that's why it starts with x squared. So there's a little memory tool for you. I think it's simple, but it works. Now, with that being said, I want you to know a few things, okay? First of all, the ellipses had a formula a squared minus b squared equals c squared. Hyperbolas have a squared plus b squared equals c squared. Now, where do these parts come from? Well, I'm going to show you c squared because that's just straight out right here. There is a focus right here, and there is a focus right here, and those two distances are both considered C. So I didn't put a focus in this one, but that would be the letter C. The focus here, that would be the letter C. All right, I'm going to show you A and B a little differently on the hyperbolas, but just know that this goes back to parabolas, all these parabolic curves, even though it's called one hyperbola, a hyperbola is actually two parabolas, and they both have their own foci. Same thing in this direction. So keep that in mind. You're going to be asked to find the focus or the foci. Now, there's your general truth. Let me pause this a second. Okay, back in action. So here's an actual sample problem. One of the things I did not say in the pre-lesson for the ellipses, and I'm sure that I said it in the actual packet lesson, but I got to emphasize this. An ellipse and a hyperbola always must equal 1. You'll hear that a few times in the packet lesson, but I didn't remember myself saying it in the pre-lesson in ellipses, so forgive me, but let's move on. So what do we got here? Well, remember what I said. I said a squared comes first, or it's the positive part. See, this is the positive stuff. Because of that minus, this is the negative stuff. So you see how this is actually smaller than this? We don't care. This is a squared. So if a squared equals 25, then we take the square root. What does that tell us? Well, it's going to start out feeling like you're trying to draw an ellipse. But then we're going to do something slightly different. So 5 what? 5 units along the x-axis. 1, 2, 3, 4, 5. Put a dot. 2, 3, 4, 5. Put a dot. Now we're going to take the square root of that. What's the square root of 49? That's 7. What's that telling you to do? Go up 7, down 7. 1, 2, 3. Put a dot. Put a dot. Now here comes the big difference. If this was an ellipse, I'd just go whoop, and I'd be done. But ellipses, if you remember, have a plus there. This is a minus. That's a definite distinction between the two. You see a minus, it's a hyperbola. If you see a plus, it's a ellipse. So what do? Next? You make what I call the hyperbola box. Now, the next thing we're going to do is make some very long diagonals. Very long. You'll see why in a minute. Now, the fancy name for these lines, you're going to forget it, but I'm going to tell you anyways. They're called asymptotes. Asymptotes are kind of like a gravitational pull. It's pulling the equation towards it, but the equation can never cross it. You'll talk a lot about that in pre-calculus, so I'm going to throw that out there. Now, the question is, remember what I told you, a hyperbola can either go like this, or it can go like this. So how do you determine which one? Is it this one, or is it this one? You know it by this. If it starts with x, it's going to gobble up the x-axis. Now the question is, so it's definitely not these, it's these. The question is, where do these come from? Well, it's already been drawn for you. It's that and it's that, because these are the ones that are going to go this way. Okay, remember I told you the asymptotes are gravitational pulls trying to pull the equation towards it? So a lot of students will get lazy and they'll go like that. And I might just go whoosh, because you're just being lazy mentally, okay? These have to go towards the asymptote. So don't you dare get lazy like that. It's going to go out towards the asymptote. Now these problems are going to they're going to ask you for the foci. The foci is going to be somewhere in here and somewhere on here. How do we find it? A squared plus b squared equals c squared. That's exactly the same as the Pythagorean theorem, but really no connection. A squared is 25, b squared is 49, that's 74, equals c squared, bada boom, bada bing, do the right thing. Remember, they're going to be over here. So I have a choice. It's going to be 0 plus or minus the square root of 74, or it's going to be plus or minus the square root of 74 comma 0. Which one of these lands us on the x-axis? This one, not that one. So that would be your foci, or where your foci are. That's it for the pre-lesson.